To solve this type of equation, the key step really is to make a change of variable. The thing we're going to write here is we'll define a new variable called capital X, and we'll let that equal to x minus pi over 4. By doing this, we're essentially simplifying our equation so that we can now work with our unit circle. So our equation will now look like sine of capital X equals 2/2. Looking at our unit circle, which I'll make a quick sketch of here, we know that sine of capital X equals 2/2 at this point P here. Why? Because the point P has a y-coordinate equal to 1/2. But that's not the only point on the unit circle with a y-coordinate equal to 1/2. We also have this other point here, which I'll write P dash, which also has a y-coordinate equal to 1/2. Now, as a result of this angle here, which is equal to pi over 6, will be a solution to this equation. But we'll also have this second angle, which I'll draw right here, which is also going to be a solution to our equation. And that second angle is 5 pi over 6. So now, going back to our equation, we can see that capital X has to be equal to pi over 6, or capital X can be equal to 5 pi over 6. Now, remember, if I'm at a point P, like the one I'm highlighting here, if I'm at point P, if I go back around the circle an entire turn, so adding 2 pi to pi over 6, that's also a solution. And I can do that as many times as I want. I'll still be at P. And, therefore, I'll still have a solution to the equation. Similarly, I could actually go around the circle in the opposite direction and go back to P, and that would also be a solution. So, in other words, if I start at the point P, whether I add or subtract 2 pi, each time I'll still be at the same point on the circle. So to write that, we actually let capital X equals to pi over 6 plus 2k pi, or capital X can be equal to 5 pi over 6 plus 2k pi. What this k is going to be an integer. It can be equal to -2, -1, 0, 1, 2, etc. In other words, each time I'm adding that 2k pi, all I'm really doing is going around the unit circle, a full turn. So, now that we've done this, we have to remember what capital X actually was. Capital X, remember, was x minus pi over 4. So, x minus pi over 4 is equal to pi over 6 plus 2k pi, or x minus pi over 4 can be equal to 5 pi over 6 plus 2k pi. We now have to simplify these a bit and rearrange them so that we have expressions for x. And if I add pi over 4 to both sides of this equation, I'll have x equals to pi over 6 plus pi over 4 plus 2k pi. The second equation will lead to x equals to 5 pi over 6 plus pi over 4 plus 2k pi. We now add those fractions together. This first equation will become, well, pi over 6 plus pi over 4 is going to become 4 pi plus 6 pi over 24. Still adding my plus 2k pi. And the second equation will become x equals to 5 pi times 4, so that's going to be 20 pi, plus 6 times pi, which is 6 pi. All of that over 24, plus 2k pi. We now simplify these fractions a bit. 4 pi plus 6 pi is, of course, 10 pi over 24. Still adding my plus 2k pi here, never forget that. And our second equation will lead to 26 pi over 24 plus 2k pi. Finally, we simplify these fractions, leading us to x equals to 5 pi over 12 plus 2k pi. And the second one will lead us to x equals to 13 pi over 12 plus 2k pi. We now have our two general solutions to this equation. And what we have to do now is consider different values of k to find the actual solutions within the domain we were asked to solve this equation. What I mean by that is, if I scroll back up for a second, we were asked to solve this equation for x between 0 and 2 pi. So that's what we have to take care of now. And the first step really is to consider the case when k is equal to 0. If k is equal to 0, this first solution will lead us to x equals to 5 pi over 12, and the second solution will lead us to x equals to 13 pi over 12. Both of these solutions are fine, because they're both within 0 and 2 pi, so they're both okay. We now have to consider other values of k. So, moving around the unit circle really, if we let k equals to 1, then our first solution will lead to x equals to 5 pi over 12 plus 2 pi, and the second solution will lead us to x equals to 13 pi over 12 plus 2 pi. But neither one of these solutions is okay because they're both bigger than 2 pi. Since 5 pi over 12 is positive and 13 pi over 12 is positive, we know that if we add 2 pi to those, the answer will definitely be bigger than 2 pi, so we can ignore them. If we now consider k is equal to negative 1, the first solution is going to lead to x equals to 5 pi over 12 minus 2 pi, and the second solution will lead us to x equals to 13 pi over 12 minus 2 pi. And both of these solutions will be negative because 5 pi over 12 is less than 2 pi, and so is 13 pi over 12. So we can ignore these solutions as well. So all in all, our two solutions are the values we found when k is equal to 0, which were x equals to 5 pi over 12 or x equals to 13 pi over 12. And there we go.